So next question is question number 2.58. Here the question says, similar to electron diffraction, neutron diffraction microscope is also used for the determination of the structure of molecules. If the wavelength used here is 800 picometer, calculate the characteristic velocity associated with the neutron. So here we are given with wavelength. So we'll write down what we are given with. We are given with wavelength whose value is 800 picometer. So we are given wavelength and we are asked to calculate velocity. So the only equation that can give a relation between velocity and wavelength in this case is going to be your de Broglie's equation. So here we can write lambda is equal to h by mv. So this equation is according to de Broglie's wavelength. So in this, when we are having this particular equation, h here is Planck's constant. M, because we're looking with respect to neutron, m is going to be mass of neutron. V is the velocity. But in this case, lambda is given to us and V is what we have to calculate. So let's rearrange this formula itself. So we can write velocity is equal to h by m into lambda. Now here let's write the values that are there. So h is 6.626 into 10 to the power minus 34 joule second. So that is our h value. Mass of neutron is 1.675 into 10 to the power minus 27 kg. This value is constant. We should know it by heart, just like you know the mass of electron. Lambda value is given to us as 800 picometer. But we can't have this in terms of picometer because here joule is there, kg is there. So we have to convert this joule into kgs. So for that, we will have to convert this value. So here I'm going to write that 6.626 into 10 to the power minus 34 kg meter square seconds minus 2. So 1 joule is this much of value in kg into the seconds that is here. So that I have done. So because I have converted and made these two parameters same as kg and kg, I can't leave wavelength in picometer. Picometer should already also be converted to meters. So here 800 picometer is there. This, when I write it as meters, this will be equal to 800 into 10 to the power minus 12 meter. So we can write that 1 picometer equals 10 to the power minus 12 meters. So we have all values. Let's substitute the values. So here h is in terms of this value. So I'm going to write 6.626 into 10 to the power minus 34 kg meter square seconds minus 2 into seconds, because this alone is joule. That's why this seconds is coming from here. Divided by mass of neutron is here 1.675 into 10 to the power minus 27 kg into lambda value is in terms of meters, so 800 into 10 to the power minus 12 meters. Let's cancel out the common terms. Kg and kg will get cancelled. Meter and 1 meter here will get cancelled. Seconds and 1 seconds will get cancelled. So now 6.626 divided by the product of these two will give us here. So let's multiply the denominator. So 6.626 into 10 to the power minus 34. What is left in the numerator is 1 meter and seconds inverse. So meter and we have seconds inverse divided by 1.675 into 800 will give 1340 into 10 to the power minus 37 minus 12 will give minus 39. Here there's nothing in the denominator, they're all cancelled. Now when you divide both of this, so 6.626 divided by 1340 will give 0.0004944 into 10 to the power minus 39. When it goes up, it will become plus 39. So that will be equal to 10 to the power 5. Only meter per second is there. That is the unit of velocity. We can't leave the value like this. So shift the decimal to one non-zero digit here. So 1, 2, 3, 4. So when you shift it by 4 decimal places, here you will get 4.94 into 10 to the power 2 meter per second. So that is the velocity for this question.